In this video, we're going to look at another example of partial fractions. In this case, q of x, the denominator, contains the irreducible quadratic factor, ax squared plus bx plus c. B squared minus 4ac is less than 0. That is what makes the factor ax squared plus bx plus c irreducible. That means it can't be factored. So f of x is equal to p of x divided by q of x. And this fraction, this rational function, shares no common factors between the numerator and denominator, and the degree of the numerator is less than degree of the denominator. Then the partial fraction decomposition will have the pattern ax plus b divided by ax squared plus bx plus c. This term can be integrated by completing the square if necessary and applying the formula integral 1 over x squared plus a squared dx is equal to 1 over a tan minus 1 of x over a plus c. This formula can be derived by the method of U substitution and some algebraic manipulation. So when we're integrating ax plus b divided by ax squared plus bx plus c dx, after completing the square, we can make it look like integral cu plus d divided by u squared plus a squared du. And we can split it up into two separate integrals. The first integral can be done by U substitution by letting w be equal to u squared plus a squared, and the second integral by the use of the above formula. So that's how we do it. Let's look at some examples. So here we want to find a partial fraction decomposition of the following rational functions. The first example, we have x plus 1 divided by x minus 2 divided by x squared plus 4. So that's going to be a divided by x minus 2 plus bx plus c divided by x squared plus 4. All right, let's look at the second example. Here we have x divided by x plus 1 times x squared plus 9 times x squared plus x plus 1. We have three factors. The first one, x plus 1, is a linear factor. The second factor, x squared plus 9, and the third factor, x squared plus x plus 1, are both irreducible quadratic factors. So we will apply the partial fraction decomposition, and we will get a divided by x plus 1 plus bx plus c divided by x squared plus 9 plus cx plus d divided by x squared plus x plus 1. So the key concept is this. The irreducible quadratic factors x squared plus 4, x squared plus 9, x squared plus x plus 1, or x squared plus a squared have the partial fraction decomposition of ax plus b divided by ax squared plus bx plus c. All right, let's look at an example. Here we have integral 3x squared plus x plus 4 divided by x cubed plus 4x. Integrate with respect to x. The first thing we check for is that the degree of the numerator is going to be 2 because 3x squared plus x plus 4, the leading term is 3x squared. The denominator is x cubed plus 4x. The degree of the denominator is 3 because x cubed is degree 3. And 2 is less than 3, so we can apply the partial fraction decomposition. All right, so what we get is a divided... No, the first thing we should do is factorize the denominator. Let's do that. We got 3x squared plus x plus 4 divided by, factorizing the denominator, we get x times x squared plus 4. So now let's apply the partial fraction decomposition, and we're going to get a divided by x plus bx plus c divided by x squared plus 4. The next step is to clear out the fractions by multiplying both sides by x times x squared plus 4. On the left-hand side, we're going to get 3x squared plus x plus 4. On the right-hand side, we get a times x squared plus 4 plus bx plus c multiplied by x. Let's expand this. We get ax squared plus 4a plus bx squared plus cx. Let's put all the terms together, all the equal terms together. By that I mean all the x squared terms together and all the x terms and all the constant terms. All right, so we get a plus b x squared if we factor an x squared between those two terms, plus cx plus 4a. Alright, so now we have 3x squared plus x plus 4a is equal to a plus b times x squared plus cx plus 4a. So clearly you can see that 3x squared, the coefficient of x squared is 3 on the left-hand side, must be equal to the coefficient of x squared on the right-hand side. Similarly, we have 1 times x, and here we have c. So automatically we get c is equal to 1. And here we get 4 on the left-hand side, that's the constant coefficient. On the right-hand side, we have 4a. So looking at coefficients of x squared, on the left-hand side, we have 3. On the right-hand side, we have a plus b. Coefficient of x, on the left-hand side, we have 1. On the right-hand side, we have c. Well, that's easy. That gives us c right off the bat. Looking at the constant coefficient, on the left-hand side, we have 4. On the right-hand side, we have 4a. So we get a is equal to 1 if you divide by 4 both sides. Divide by 4. We have a equals 1, c equals 1, and we can solve for b by looking at the first equation. 3 minus a is equal to b. B is equal to 3 minus a, b is equal to 2. Alright, so what we have is a is equal to 1, b is equal to 2, and c is equal to 1. So now we can do the partial fraction decomposition. We have 1 over x, that's a over x, and then bx plus c, that will be 2x plus 1, divided by x squared plus 4. So the partial fraction decomposition has been completed. Alright, so now the time comes to integrate. We have integral 3x squared plus x plus 4 divided by x times x squared plus 4, and we have applied the partial fraction decomposition process, and we have integral 1 over x plus 2x plus 1 divided by x squared plus 4. Let's split up the second term, 2x plus 1 divided by x squared plus 4, as 2x divided by x squared plus 4 plus 1 divided by x squared plus 4. Alright, so looking at the integration, what we have is integral 1 over x dx plus, and the second term was split up into two separate terms, and splitting up the integrals further, we get integral 2x divided by x squared plus 4 dx plus integral 1 over x squared plus 4 dx. Integrating the first integral, we get log of absolute value of x. The second integral can easily be done by substitution method, and we get log of x squared plus 4 divided by 2. And the last integral can be done by using the identity, or I should say the integral we had earlier. This is going to be 1 over 2 tan minus 1 of x over 2, the formula that we talked about earlier. Alright, so what we have is, you can see that we basically applied U substitution for this integral by letting u be equal to x squared plus 4, and du is just 2x dx. And for this integral, we applied the formula that we talked about earlier. Let's write that down. We have integral 1 over x squared plus a squared dx is equal to 1 over a tan minus 1 of x over a plus c. Alright, we have solved the integral. Now let's do a bit of review on integration, the U substitution. So let's say we have integral 1 over x squared plus 4 dx. And we didn't want to apply the formula. So the first step would be to divide by 4 everything. So divide numerator and denominator by 4. We get 1/4 integral 1 over x over 2 all squared plus 1 dx. Now applying U substitution, we get u is equal to x over 2. du is 1/2 dx. dx is equal to 2 du. So applying the U transformation, we get 1/4 integral 1 over u squared plus 1 times dx, which is 2 du. Removing the 2 outside the integral, we get 2 over 4, that's 1/2, integral 1 over u squared plus 1 du. And that's 1/2 tan minus 1 arctangent of u plus c. Putting u back in, we get 1/2 tan minus 1 of x over 2 plus c. So clearly you can see applying this formula is a lot easier. All right, thanks.